This is my first update for Nehari, which sometimes I will call Nehari, but I'm trying to do better, and I think I've been lately calling it Nehari. So it's Nehari. Sorry, Nehari. The book is great, reads very well. It's an older book, it's a Dover book. Dover books need to be treated with care because sometimes there's notation that is a little weird, it's old, and I have encountered a few, and yes, incredibly enough, I thought it was perfect, but it does have at least one typo. Very minor, nothing special. So as far as reading is concerned, I have read all of chapters 1 and 2. Chapter 1 is, I would call it fairly unwelcoming because it is hard, very hard. It's all about harmonic functions. Now this book has already satisfied its minimum requirement for what I needed from it. I wanted to answer a question from an example that I saw in Sept and Snyder, where Sept and Snyder arbitrarily said, well, with what we know by now, the harmonic function should be something of the form argument of z. And I was like, what? Where'd that come from? And actually, if I go through in Sept and Snyder, I'm not sure that I could have known that. Now I know from here, because this book really goes into incredible detail of what a harmonic function is, what is the general form of a harmonic function, what is the vector calculus for it, why you get all these relationships with normal vectors. And sure enough, once you get used to the form of a harmonic function, I keep going back to, like, it's usually negative log r plus some other function. And then they explain in great detail what happens to all the variations of that function, right? So it's negative log r plus something. And of course, this function, double derivatives of x and y, gives you the Laplacian at equals 0. And then, but it goes further, because then it starts talking about the Green's function, which is put into the integral that gives you the harmonic function. And then the Green's function itself is also harmonic, negative log r plus a g1. And so, yeah, it's very thorough. Then there's also a whole set of boundary conditions that are used for what are called Newman functions. And Newman functions are all about the derivative of the normal vector. And then also Newman functions can be reduced to it's called the second kind. The second kind is the Newman function boundary conditions can be reduced to the first kind, which is the Green's function case, which is the Dirichlet problem. And so, yeah, very well explained, but boy, has it been difficult. I've read through the whole thing, of course, the whole chapter, and I believe that I'm going to do a much better job of understanding every detail and solving a lot of the problems better and correctly after I do a Fourier series course and after I revisit vector calculus. Both of those things would happen before I fully would understand, just cruise through this. I did not cruise, but very thorough. My head hurt when I was reading it. Multiply connected domains, the last section is tough, very tough. But again, yeah, it's just something that I wanted to do. And then, of course, the beauty of it is after you go through the first chapter, at least in my case, then, since I've already read Sept and Snyder, chapter 2, analytic functions, it's just straight out of any complex book, and it's just cruising. Very easy read. All of this material, I mean, I'm familiar with. Again, but with a little more rigor, a little more Power Series talk, which I love because Power Series kicked my butt when I was reading Wade. And so, yeah, the reading has gone great. Now, as far as progress is concerned, as I mentioned before, read all of chapter 1, read all of chapter 2. So there you have it. That's what I've done so far. And then, of course, just the obligatory, just showing the notes. Go through it quickly because I've already shown the book and it's fairly duplicative. It had a really good explanation of the point at infinity, better than Sept and Snyder, so I went through it. Very useful. Yeah, definitely. I love the way he did it. Nehari, Green's formula, as I mentioned before. So yeah, when you start this book, it's clear that you have to have had some complex analysis to really understand it. And if you don't, it's very interesting because a lot of the concepts that are laid out in the first chapter are things that I would definitely want to have complex analysis knowledge to read. At least I felt that way. There's a lot of discussion on contours without anybody telling you that it is a contour. Anyways, then of course there's a lot of Poisson's formula discussion. Yeah, a lot of Poisson. Then the Newman function, how it can be reduced to the Dirichlet problem. Yeah, just a lot. Chapter 1 was a bear to read, and I thoroughly enjoyed it because I love the pain. And then eventually you land on equations when he describes the vector calculus of conformal mapping. You get the Cauchy-Riemann equations without him calling them as such. Then, yeah, as I mentioned, multiply connected domains, difficult read. Then I did a bunch of problems, which some were straightforward, some were easy, and some were very difficult. Now, I don't have answers in the back of the book, but I know when I did something right. Of course, in the case of if they give you a function to test if it's harmonic, if you get 0 for the some of the derivatives, you're there. I tried to work on these derivatives of functions where all you have is the argument inside the function. I could do the basic one of u of xy. I couldn't do the one in the problem. So this is a come back to someday. Yeah, actually, I think I need to do this. I'm sorry. There you go. That's better. That's better. So yeah, I need to come back to these problems, to this particular problem. Then a very simple problem, like that probably took me a few minutes. But then to show that the harmonic function for the Poisson formula is harmonic, to do the derivatives, I don't know. I think I did it right. I'm not sure. I mean, I calculated it multiple times, even to the point where I started coming up with a mnemonic where each of these terms, I just abbreviated them. Otherwise, the algebra was just going to get too big. So at least I learned that, and that's helping me in other problems that I've done. But I think I got it right? I don't really know. It sucks when you don't have the answers. Yeah, it sucks when you don't have the answers. But I have to get to the point where I grade myself and I'm like, it sure looks like I solved that problem. And I just have to live with that, I think, for this particular book. And that's fine. That's fine. Some of the proofs I just had problems with. I'm basically restating what they asked for. I don't feel like I proved it. But yet again, in some other cases, in this case, I think I nailed it. Because you take the function they give you, they say, well, is this a Green's function? Well, forget that it's G. Just say, is that a Green's function? Sure enough, when you take out the term of negative log R, whatever is left to your G1 is a term that when you differentiate it, you get to a harmonic result. So yes, it is. It is a harmonic function. So at least I solved that. So that's my progress so far for Nehari.